In the previous video, we did problems on one other type of differentiation, correct? Double order or second order differentiation. See, till now, whatever we have learned, whatever we have discussed, we have done problems, everything, it is based on one derivative, and you are doing the differentiation, finding the value, doing the proof, proving LHS is equal to RHS, all the different types of problems, correct? Also, if you look at all the things, there is one thing which is common in all of it. That is, you had an algebraic formula, you are formulating, and you are getting an answer, correct? That's all. Now, in this particular video, you are going to understand two very important theorems. Now, these two theorems are based on the differentiation whatever we have done. Now, you can also, relate that these two theorems are going to help you in understanding what is the geometrical meaning of derivative. All right. Now, the geometrical meaning of derivative and everything will come to that part later in the next chapter. Whereas this is more like a precursor for the geometrical understanding and interpretation of what is a derivative. Understood? Now, this particular video, we talk about very two important theorems. Now, they are called as mean value theorems. Alright? So, mean value theorems. Now, generally when we say mean value theorem, now there are two parts in this one. The first one is what we call as Rolle's theorem. The next one is called the Lagrange's mean value theorem, or just in general, we call it as the mean value theorem. So, now when we say mean value theorem, generally you can call it as MVT, mean value theorem. Now we are going to discuss both Rolle's theorem as well as the mean value theorem. Alright, now let's start with what is Rolle's theorem and what does it indicate, what exactly does it give you. Alright, so let's discuss about the Rolle's theorem now. Now when we talk about Rolle's theorem, see in Rolle's theorem what we do is, first we take a normal function f of x, alright. Say you have a function, something like this. Some function is there, alright. Let's say we'll take 2 points within this function. So this is 0 and this function, maybe we can call it as f of x. Some function f of x, alright. So here we are going to take 2 points. Alright, so let's mark 2 points here. Say 1 point, maybe we can call this point here as A, and let's say this point is B. So we have 2 points A and B. So when you have points A and B, you're going to have f of A and f of B, correct? So we'll come to the f of A and f of B later on. What this particular theorem, the Rolle's theorem, what does it tell you or what does it state? Is basically, see this one. So you have a function f, correct? So f is from A comma B to R, and it is in such a way that it is continuous in A comma B and it is differential in A comma B. You guys are seeing this definition, correct? Now, once you have it is differentiable in A comma B, there exists a point C such that f dash of C is 0. And C is a point. Where is the C point? It's between A and B, isn't it? So, what we have now is, if you look at the graph, we have A and B. Now, what we'll do? So, we are going to take one point C. This is going to be C. C is in such a way that the slope of the line, something like this. The slope of the line passing through C will have a 0 slope. Or you can say that the line is parallel to x-axis. Because any line parallel to x-axis slope is 0. So what we have a function f of x, and this is first is it has to be continuous, correct? So it has to be continuous in a comma b, the first case or the first condition, or this is how you define it. All right. So this is the first part. Then also it has to be differentiable in a comma b, correct? So if both of them are true, then we have a point C. See, look at this one. So you have a point C. This point C is between A and B, correct? In such a way that f dash of C is 0. That means you are going to have f dash of C is equal to 0. Clear? So this basically tells us the Rolle's theorem. So Rolle's theorem talks about a particular point C in a given region A comma B. Understood? Now here a very important point is the point C, whatever we are looking at, the tangent at point C is always parallel to x-axis. Hence the slope, that is f dash of C, is 0. Clear? Now let's understand what is that mean value theorem. Alright? See now what we have. You have mean value theorem. Now to do mean value theorem, so what we are going to do, again take the x-axis, y-axis. Okay. Say my graph is going something like this. Some random graph. Alright. Now what we do is we are going to take 2 points. Say this is one point A, say one more point B. Fine. So from A, so go on. From B also go on. See why we are doing this is this point is going to be f of A, and this is nothing but f of B, correct? Now what mean value theorem states is that if we have a function f of x, like see this function is f of x. If we have a function f of x, then that particular function has to be continuous in a comma b. So first and foremost, f of x is, it has to be continuous. So continuous in a comma b, differential in a comma b, like differential in the sense you should be able to differentiate, correct? So once you have these two, now comes the most important point, that is there exists a value c. Okay, some value c. So some value c is there where you are going to write a tangent. So the slope of the tangent is, I would not say 0, but the slope of the tangent is the same as the slope, or you can say the secant between point A and B, the slope of the line or slope of the secant. That's a better word of telling. So in the sense, here what we'll do, first we are going to add this f of A and f of B. Add in the sense like join. Now this particular line, whatever you have, now it might look almost parallel to x-axis, but it is not. Alright. So between f of A and f of B, we are going to draw a line. Now there exists a point C between A and B. Is, it is in such a way that the slope of the tangent at C is equal to the slope of the secant, which is between f of A and f of B. So in the sense, here I'm going to have a point somewhere over here, which is C. So if you are going to draw a line like this, see this line and this line, it should be parallel, and it will be parallel. Alright, so this is basically the mean value theorem. Alright, so mathematically, how we do it? Mathematically, so you can write f dash of c is equal to f of b minus f of a divided by b minus a. This becomes the formula for the mean value theorem. Clear? So, what did we discuss in this? We did Rolle's theorem and mean value theorem, correct? See, Rolle's theorem, it's going to be that you are going to have a graph where the slope of the tangent will be parallel to x-axis, but that point C is in the mid interval. You can say the mid, whatever the middle value or the in between value of a and b. But when it comes to the mean value theorem, now it need not be parallel to x-axis, correct? So that's why we are going to have f of b and we are going to have f of a. Like, once you have that f of b and f of a join, that's going to be a secant. The secant is a line that has a slope. You are going to have a point C between A and B in such a way that the tangent of the line and tangent of the secant both are one and the same. See, when I say tangent of a secant, what I mean is the slope of the secant. Alright, so I mean that makes more sense. Slope is nothing but tan theta, isn't it? So if you're okay with that, that's well and good. Otherwise, you can look into this one. Alright, so this is basically mean value theorem. Fine. Now in the next video, we'll solve few problems on this mean value theorem.